this video, I'm going to talk about the distribution of sample means. So previously we said that, okay, we have done a test on a stress reduction method, and then we said that we know that this population has got a normal distribution. The stress level scores have got normal distribution with the mean of 40, a standard deviation of 10, and then we had a score of 1% and it was 25. Then the question was, how about if we have a sample of size 2 and the mean score be 25? How about a sample of size 20 and the mean score is 25? And that's why we are now talking about samples and population. Now, the distribution of sample means, what is it? It is a collection of sample means for all possible means for the all possible random samples of a particular size n. So that can be obtained from a population. So that is what I explained for you. Imagine that from the population you take thousands of samples of size 10 and then put back the sample back to the population and take another sample of size 10, then another sample of size 10 and get all these X bars. Now, distribution of sample means is a sampling distribution. It is not the distribution of the individual scores. It is the distribution of sample means. All right? It is the distribution of a statistic, not a score. Now, to construct the distribution of sample means for a specific population, you would select a sample of a specific size. All right? Calculate the sample mean and place the sample mean in a frequency distribution. You have to select repeatedly different samples from the same population and record the means and then add them to the frequency distribution. This is the way I want to show you how the theory has proven that the distribution of sample mean is different from the distribution of population of the individuals. Now, in a StatLab 5, you will look at the different population distributions and take samples and have a look at the shape of the distribution of the sample means. And as you take 1,000 samples and get the sample means and the mean and the standard deviation of the sample means. Okay, so the distribution of sample means, what we mean is, imagine that you have got all these means, X bars, okay, of samples from the same size, X bar 1, X bar 2, X bar 3, X bar 4, thousands of X bars. And you're looking at the frequency distribution of these X bars. And you want to see what would be that frequency distribution, because we said that in the hypothesis testing procedure, we need the comparison distribution. What is that comparison distribution? Comparison distribution is the distribution that you look at your observed value that you have got and put it in that distribution and say where about in that distribution that observed value is. Now, the distribution of the means of a large number of samples of the same size would make the distribution of the means. And each sample is randomly selected from the same population of individuals. Now, let's have a look at an example to understand what do we mean by distribution of the sample means. So here is population of 4 scores. We have got 2, 4, 6, 8. And this is the display, the bar graph display of this sample. It is 2. This would be our population actually. So let's say you have got a population of size 4 and there's 1, 2, 1, 4, 1, 6, 1, 8. All right? Now, for our example, the population mean is 5. So 2 plus 4 plus 8, and you divide the 2 plus 4 plus 6 plus 8, and then you divide it by 4 and you get 5. Now we take all the possible samples of size 2 from this population, get the mean of these samples of size 2. Now we say that, okay, for example, now here I have a look at here. My first sample, the first number is 2, the second number would be 2, and the sample mean will be 2. The second sample would be, my first sample would be 2, the second one is 4. So 2 plus 4 is 6, and 6 divided by 2 is 3. Sample mean is 3. Okay? And you go and you will see that you can take 16 samples of size 2 from a population with a score of 4 individuals in it. Now, once I got all the means, then I make a frequency distribution. And you can see that the frequency distribution, which would be the distribution of sample means. Remember that what did we do? We had a population of 4 numbers, and then we take samples of size 2 and got the X bars of these samples, and then do the histogram of that. And you will see that its shape is a normal distribution, and it goes like this: symmetrical, unimodal, and this is the distribution of sample means of size 2. The mean of the sample falls in the 5, which is the population mean. But the standard deviation of the sample means would be different. It would be smaller. Now, as samples are representative of the population they are coming from, and their means should pile up around the population mean. The pile of sample means should tend to form a bell-shaped curve, and the larger the sample size, the better representative they are of the population. Now, therefore, the sample means obtained with a large sample size should cluster relatively close to the population mean. And the sample means obtained from small samples should be more widely scattered. Can you see that? Because smaller sample, they tend to have X bars further, and then it would be more spread out. So the standard deviation of the sample means is called a standard error. And here is a graph to tell you that as the number of scores in the sample increases, then the standard distance between the sample mean and the population mean decreases. All right? So here, if I have samples of size 10, okay, if I have got a sample of size 1, then my standard error would be 10. If I have a sample of size 4, my standard error will be 5. And as my sample size gets bigger, my standard error, which is the standard deviation of sample means, gets smaller and smaller and gets close to 1 even. All right? Now, this is the important theorem in statistics, and it is called central limit theorem. And it says that the description for the distribution of the sample means, the mean of the distribution of sample mean is the same as the population mean of the individuals, and the variance of the population of the distribution of sample means would be the variance of the population of individuals divided by the number of individuals in each sample. And the standard deviation, you know, would be the square root of the variance. And shape of the distribution of sample means would be symmetrical and unimodal. It would be normal. So that is enough for this video, and I'll talk about the next video next time.